Hello and welcome back to our tutorial series explaining how the carbon garment processors using CLO work. So here we are looking at Maya and then the welded CLO garment processor right here. In our previous video, we've set up an avatar, and a t-shirt in CLO, and we prepped it for export and we exported it. And now let's move on to the next stage. So the first thing we want to do is make sure our Houdini engine plugin is installed. The first we can see here is Houdini actually has a shelf installed, so that's already a very good sign. What we then need to do is go to Plugin Manager and type in Who for Houdini, and we see it is loaded, and we might also want to click Auto Load, so it always loads. All right, once we know this is all done and sorted, we go to File, and we can import. Now let's get started. We're gonna import our welded mesh. There we go. We have a welded t-shirt, and I'm just gonna name this Start for shorter name. Then we're gonna import our render mesh, and this comes in as panels. But since we're dealing with the welded garment processor, we're gonna have to merge some of the panels. All right, so we have this pattern 2D, and all of these are the panels. We select them. We go to Mesh, and we go to Combine. This combines them into one single mesh, but it still has a history on it. So I like to select it and press Ctrl D. So this is a new independent mesh. I call it Render Mesh, or just Render. And that means we can delete all of these patterns. And these are the, oops, this one too. And these are the details, these four. So what we can do with these, actually just leave them as they are, but maybe we put them in a group. Details. All right, so we have Start, we drag out details in here, and we have Render. Perfect. Now let's get the avatar, File, Import. Where is our avatar? Here we go. All right, and the avatar comes as a bunch of pieces as well. So we can just create empty group again, call it avatar. And we're just gonna drag this one in. All right, looks like that was a naming config, so it's added the two, but doesn't matter. All right, what I like to do now is actually select all of the meshes, select them, select hierarchy, and then I like to actually unlock the normals and soften edge, just so we get rid of some of the ugly CLO normals. All right, so we have all of this set up. It might be worth pressing Ctrl S to save our scene. Now let's get cooking. We have our welded carbon garment processor CLO. Click on it to create it. It shows you from top down what we need to do. Metadata XML. Yes, we have that one. We exported it. And here is double click. Perfect. Okay, we need a simulation and a material. Click on the simulation node. This creates a carbon simulation. I like to set my subdivisions to 30. And I like to set my length scale correctly because otherwise the simulation is gonna look wrong. So length scale, how do we set this? We exported everything in centimeters, or scene units as centimeters. Like this is 186 tall. Carbon expects in meters, so we need to use this length scale to tell carbon actually what you're getting is not meters, it's centimeters. So we set to 0.01 because a centimeter is 100th of a meter. All right, and then I'd also adjust the linear motion to 100. All right, let's create a cloth material. You create this node, and you have the option to load from existing presets if you have one, and if you don't, that's fine. Adjust the thickness, again, we're in centimeters, so we want to say 0.1, that means 1 millimeter. I like to make my stretch stiffness 100, my viscosity 2, and my bend viscosity 2 as well. And that's usually a pretty good starting point. All right, back to the garment processor. Simulation, yes. Material, we have that. Start, let's scroll down, find our Start. Render, we have a render mesh. Click on Render. And you might notice that sometimes you need to scroll a bit. If you have a lot of meshes, it can take a while to scroll, or not all might be displayed. So what you can do is you select what you want in the drop-down, press Control, then click on your node of the drop-down. And now in the drop-down, it will have whatever you selected first as the second option after none. So you can let go of control and just select details. There we go. We have a save, and let's move to stage 2. And thus it asks us if we want to delete the history of the meshes. And I usually say yes, because I just want a clean slate basically. delete history. All right, now here's the reason why we have the Houdini plugin loaded, because we're gonna use a carbon remesher Houdini digital asset, HDA, Houdini digital asset. And you should have been provided this with your plugin installer. All right, double click. And in here, a bunch of nodes, but the one we want is a carbon remesher. You can ignore the other ones. Okay. And this will create a carbon remesher node, which remeshes the mesh into a carbon-friendly format so we can easily apply our wet warp and bias parameters. Everything should be set up properly, our triangle count, because it takes a start mesh into account, and you shouldn't really have to do anything here, and usually you can just ignore it and go back to the carbon garment processor and move to stage 3. There we go. Now we're in stage 3. It asks if we want to merge details. All right, let's go to details. And we have 4 details, and sometimes you have a lot, like dozens or hundreds, and you really want to merge them just to slim down the graph. But with 4, we don't really need to do this. We can just move on to stage 4. All right, now we have the simulation set up. All right, I'd say let's hide some of the other things. Let's hide the render and the details. And look at the simulation setup. We have a cloth that's set up, and we also get a Creases node. So what does the Creases node do? It takes data from the XML file. All the edge groups, which are like groups where you have seams enclosed, or we have panels stitched to each other. And it also takes internal folds that you might have set up and then applies those parameters. So we have our angle, which is a fold angle, and the strength is a fold strength in CLO. And those values come directly from the XML file. And down here, you see the original value. So we had angle XML 0 and strength 5. So if I was to play around with this at some point and I want to go back to what it was originally, I can always spot it here, go back to 0. For each of them, you can set a color, which is already applied by default. So the first one is actually here. And if we zoom in, so we have the name of the Creases here as well. So that's 0. And if you look here, that is Creases shape 0. So these names match the names in here. If you look for one, oh, that's 13. Again, go down to 13. Or it is. And then we have the parameters here. I can also enable and disable it as to like, do I want to actually force a fold strength and angle here or not? But yeah, that's all set nicely default, and we don't really have to do much with it at this point, because we need to see first how it simulates, and then you can tweak it if you want. When I'm done with this, or I don't need to see the font, I just hide it, press H. There we go. But yeah, let's have a look at simulation. There we go. There it goes away. Why? Because we only have the cloth simulation set up. We've seen avatar, but this is just the geometry. So let's go to the avatar. We can either pick it up in here, or we just click on this. Mesh is the body. Click on our carbon collider. All right, carbon collider. We do not have animated geometry. It's just static apose, and we need to adjust the thickness. Again, we're not in meters, we're in centimeters. Let's remove 2 zeros. And we have 0.1 centimeter, which is 1 millimeter thickness. Reset the simulation, and there we go. Now we have our cloth simulation, which looks quite nice. And you can obviously tweak from here, play with the simulation parameters or your cloth material. This is what the cloth links to. And yeah, but we're not done yet, are we? Because we have our render meshes and render details. So I'm going to hide the simulation, and we're just going to have a look at this. Hide the avatar. All right, so our render meshes will be, or our render mesh, which is panels, will be mapped to the reference mesh of the cloth simulation. And the details will be mapped to the render meshes. So we have 2 basically sets of deformers. But now what you see is that our reference meshes, which are on the XY plane with a set value of 0, actually do not overlap the render meshes. So reference meshes here and render meshes are off. So this is because when you export flat panels from CLO, you actually end up in a situation where a set value of plus 20 is baked in. We would just counteract this by going to the transform and setting minus 20. And we need to do this for the render meshes and for the details. All right, that's with a save, Control S. All right, so now they perfectly overlap. We can go back to garment processor, and we can go here to section, say apply deformers. Click it, it's going to calculate the deformer. And if we look into details and render, we have one deformer which maps our render meshes to our simulation mesh, and then we have 4 deformers, which maps our details to the output of the first mesh deformer. So make sure we also see the right things. So we don't want to see the start meshes, we don't want to see the reference meshes. And render, we want to have the deformer output. That's correct. Let's have a look at here. Do we see a thick mesh? Yes, we do see a thick mesh. Perfect. All right. Maybe we also want to show the avatar. Let's bring back the avatar, and the body is hidden. Let's bring back the body. Beautiful. And there we have our setup, our deformer setup. And you can go into each deformer. You can change the deformer mapping type. You can obviously go back to your cloth. So if you just want to tweak the simulation, you might just want to hide render and detail and show the simulation node. Then you can tweak your simulation, and once you're happy with it, hide the simulation with H, unhide the details with H, show the render, and you can continue in here. And yeah, I hope this all makes sense, and happy simulating. Thanks for watching.